section 1.7, we're going to be doing combinations of functions and composite functions. But first, we're going to talk about the domain. And I'll give you just a minute to read through that, so I'm not just reading it to you. And then I'm going to pause it for a second and add some comments that we're going to talk about more specifically in just a minute. The biggest thing that you want to make sure you notice is that division by 0 will result in an even root of a negative number. Okay, so basically we cannot have division by 0. And we're going to look at some different cases that I'm going to write down, and we'll get to some specific examples in just a second. So this was not on your notes, but you may want to add these category and domains, because when we see our examples, this is a good chart to come back to remind yourself. When you have a polynomial, the domain's just going to be all real numbers. There's no restrictions. A rational number, which you want to think of a rational number, is like a fraction. Remember, we can't have 0 in the denominator, so we want to know all the places in which that happens so we can say that's not part of the domain. A radical, which is our square root, basically we're going to take the radicand, set it greater than or equal to 0, and find our domain in that way. Why do you think it's greater than or equal to 0? Because if you have a square root, if we're thinking about a radical right there, we can't have a negative number under there. If you remember from college algebra, square root of a negative number is an imaginary number. Square root of -1 is your I, and we want to ensure that whatever it is under here is greater than or equal to 0, and all that means is to guarantee that this is a positive value. That's all that means right there. So we're going to be checking that out in just a second. So the first function we have is f of x equals x squared minus 7x, which this is, look at our categories, because our categories are only the ones that we're going to be talking about now. Now, as we go through the course, we're going to add more to our category, so to say, but for today's lesson, we're mostly looking at those 3 cases. Which case is part A? It's simply a polynomial. Good. Actually, it's a second degree polynomial. Not that that matters, but just for extra info. So what is the domain going to be? All real numbers. I can either write the words all real numbers, or set notation, or interval notation. This is interval notation. Negative infinity to positive infinity. Good. Okay. Let's look at B, which is g of x. Would you say, what category would you say B falls in? Rational. Good, because we think of it like a fraction. So when we have a rational function, we take our denominator and set it not equal to 0 and solve. So we know x cannot equal 3. Why not? Why not? Well, if I put a 3 right there, what's 3 minus 3? 0. And can you ever have division by 0? No. So that's exactly what we're looking for. So basically, the domain for this problem is going to be everything except for 3. So set notation, just so you see set notation occasionally, we would say the domain is equal to all the values of x such that x is an element of the real numbers and x is not equal to 3. Okay, this is red, this is set notation x such that x is an element of the real numbers, but x cannot equal 3. The one we use most often and one we're going to use by default is going to be our domain interval notation, which is going to be from negative infinity to 3, parenthesis. Why can't that be a bracket? Because a bracket would mean that it's included in the set, and we know we can't include it in the set. So then I would say union from 3 to infinity. Now, if you struggle with set notation, I highly recommend that you just sketch a graph of it and basically put an open circle at 3 that says, I can't use that point. It's not defined there, so it would be everywhere else. And then that may help you with interval notation as you read it left to right, because that would be negative infinity to 3, union 3 to infinity. So if you struggle with set notation, it will possibly go back, help you to go back and draw a rough sketch of it. Okay, C. Well, it is polynomials, but more than that, it does have polynomials in it. But what is it? What category? It's rational. So we need to figure out, um, set this denominator not equal to 0, so we get x squared minus 2x minus 3, not equal to 0, and solve. Now, I'm going to go out to the side and use bottoms up to factor this. You can use whatever method you like, and I'm only going to pause it and then show you a quick look of that. Okay, you can see from the example, we're going to come over here and put x plus 1, x minus 3 cannot equal 0. And now we set this not equal to 0 and solve. And we're going to set this factor not equal to 0 and solve. And we find out that x cannot equal negative 1. We do the same thing on this side, and x cannot equal 3. So let me move this so I can save some room. We want to write our domain. If it helps, I'm going to start with a sketch. This may help with interval notation. So I have a negative 1 and a 3. Make sure they're in order on the number line. And we say x cannot equal this, and it cannot equal this, but that means it can be everything else. Okay, so now we want to practice writing that in interval notation. So we start with our leftmost, which is going to be negative infinity to negative 1. Then we put union, and then it picks back up from negative 1 to 3, union, and then from 3 to infinity. And this is our domain. Okay, D, we're going to look at h of x. What category, which category is this fall under? Radical, right? So for radical, we say we want to make sure that that radicand, or we want to make sure that the expression under the radical, more so, is going to be greater than or equal to 0. So basically, we want to make sure that that's positive value. We're going to solve this. So 3x. Solve this for x. And x is greater than or equal to negative 4. So the domain, let's just draw a sketch so if it helps. So if we have negative 4 greater than or equal to, that means I'm going to have, because of this equal to bar, it means I have a solid circle. And greater than means I shade to right. Good. Good job. So we shade to the right. Now let's name that. How will we name that? The domain is equal to bracket negative 4 to infinity, and we always write the domain reading left to right. Okay, make sure you're always reading left to right when you write your domain. And I'm throwing in an extra, which is e, and I want you to try this one on your own. So f of x is equal to 1 over square root of x minus 5. Try this one on your own. Good. So we see that it is a radical and it is rational. So we test both conditions. And this particular one says if we were to graph just this, it would be greater than or equal to 5. But then when we come over here, this says, oh, but x can't equal 5. So in that case, it would override it, and it's an and inequality Well, it's and because they both conditions have to be true. So this is a particular solution that makes it true for the given conditions. So this is just going to be parenthesis 5 to infinity. So our domain is going to be from 5 to infinity.